You know what we didn't do? We didn't do any intro music. Which one should we do? This is the way?
Yeah, this is the way.
This is the way.
This is the way. This is the way.
This is the way.
This is the way. This is the way. This is the way.
This is the way.
This is the way.
This is the way.
This is the way.
This is the way.
So today we'll be learning about training.
You're going to be learning about training?
Yes.
So what are you going to learn about training?
To do new things.
I don't know if that's what we're going to be learning.
Okay. So, training is a kind of hard thing, so it's kind of really hard, so you might not like it. So, let's start. And we will talk about it.
Okay, sounds good. How about we do... see if you can do any of these on here.
Okay.
So we're going to watch on this screen over here. All right.
Let's start.
And finally, let's look at the last of our three elementary linear electronic components and learn a bit about inductance and inductors. Here is inductance in our list, and it's measured in units of henries. An inductor is just an electrical wire that's coiled into a helix or a spiral. It's also called a coil, a choke, or a reactor. The symbol for inductance is this half-looped shape, much like the real coil of wire would look like. It's indicated in our simple electrical circuit by the letter L. Well, wait a minute. Why L? Well, that's in honor of the physicist Heinrich.
What you got to say?
Training's about training a kid or a dog or anything that you need to train.
Okay. Are you watching?
Yes.
See if you can learn.
Who did extensive work on electromagnetism. But the unit of measure for inductance is the Henry, in honor of Joseph Henry, the guy who discovered self-inductance and invented the inductor. So you represent an inductor in a circuit by the letter L, but you measure its inductance in henries using H. To understand inductance, we have to start super simple. If we have a straight wire and there's an electric current flowing through the wire, then that flow of charged current will create a circular magnetic field around the wire. You can see in the photo how iron particles are lined up in circles around a wire that's carrying current. This is why the whole field of this...
What?
I would tell people that
You got talking to the
belongs
microphone.
the water. Sometimes they go to the water. From these gold things, they will go to the water, and it's more different from
Are you listening, though?
Oh, yeah, I am.
Okay.
This science is called electromagnetism. Electricity cannot be separated from magnetism. They actually cause one another. This phenomena of a wire creating a magnetic field around itself is called self-induction. If you wrap that wire into a circle or a coil, then the magnetic field lines going around the wire will get added together inside the coil, and it will create a magnetic field just like a magnet, with a north and a south pole. Convention says that the north is where the magnetic field lines come out.
It's like science class, huh?
In the illustration, you can see the lines adding together inside. And in the photo, you can see how iron filings show the concentrated magnetic fields inside the coil. You're basically making an electromagnet. To enhance the concentration of
You wanna try and
magnetic
do
field
this
lines
afterwards?
and the amount of energy,
You want to make
there's
a magnet?
usually an iron core in the
Yeah.
center of the coil. Just like for capacitors, there's some dielectric material between the plates. An iron core can increase the strength of the magnetic field by thousands of times. Making a simple electromagnet using a nail and some wire and a battery is a great way to see self-induction in action. Okay, it's time to look at some practical examples of inductance used in real electrical products.
All right, Maddie.
Okay.
This is called a relay right here, all right?
A relay.
This is a contactor, okay?
A contactor.
This is a solenoid.
Solenoid.
This is a transformer.
Transformer.
This is a motor.
Motor.
Okay.
Electrical components that we use every day are relays and contactors, solenoids, transformers, and motors. A relay is an electrically operated switch. It's commonly used to control another circuit. For example, a low-power 12-volt circuit with a relay could turn on and off the current for a different circuit with a large current and voltage that operated a heavy load. It uses an inductor as an electromagnet controlled by one circuit to pull down an armature that either opens or closes a connection in another circuit. Let's take a look at how that can happen. This is how a relay operates. This example has two contacts, one that is normally closed, or NC, and another that is normally open, or NO. So when the relay is at rest with no current in the coil circuit, then the spring holds the armature up against the NC contact and away from the NO, or the normally open contact. It just stays this way until current is applied to the coil terminals. Current in the external circuit, the big one being controlled by the relay, would flow from the common terminal through the armature onto the normally closed contact and out from the normally closed terminal.
You all right there?
But when current is applied to the coil circuit, then the electromagnet is energized. The iron core inside the coil concentrates the magnetic field to have more strength, and the electromagnet pulls against the spring and brings the armature down, breaking away from the top normally closed contact and stopping that circuit, and making contact now with the lower normally open contact. Current in the external circuit, the one that's being controlled by the relay, now would flow from the common terminal through the armature and onto the normally open contact and out of the normally open terminal.
Pay attention.
Presumably, that would route the current to do a different job in a different circuit. If the relay was a simpler design with just one set of contacts, then the action of the relay would be either to just open a normally closed contact or close a normally open contact. Contactors are very similar to relays, with relays just generally being used for smaller currents and contactors being used to handle larger currents, typically to handle more than 15 amps or 3,000 watts. One cool feature of some contactors is that they can be latching. This means once the internal electromagnet pulls the armature into position, a mechanical arrangement holds the contacts in place. The power to the internal coil can go away, and the contactor keeps the circuit switch position
Better be paying attention
until
because we're going to
told to
questions at
release
the end.
by another pulse of signal power.
Okay.
This can be useful where control power might be unreliable, or where you want to reduce power consumption, or where you just want to control another circuit with a momentary push of a button instead of having to keep the coil
How are you
energized the
hungry?
whole time. A solenoid is more of a mechanical device used to
You're worse than a technician. All you think about is food, drinking, and not working.
allow remote electrical control of valves for liquids and gases. Here's an animation showing how a solenoid can control the flow of a fluid. When the solenoid power is off, the spring holds the plunger down, forcing the fluid to go in one path. But when there is power to the solenoid, the electromagnet pulls the plunger up, sealing the first path and opening a different path for the fluid to flow. Transformers use inductance to create or induce a voltage and current
Do you want to see if we can take the test?
Oh, yeah.
Then we'll take a short break and you can go get a snack. Actually, no, we're not doing a snack because it's almost dinner time. You have to get through these videos before you can earn the credits and complete the course. Let's do the knowledge check, Maddie. What is the unit of measure for inductance? Is it EMF, Lens, Henry, Joule/volt?
Joule/volt.
You failed.
What?
It's Henry! Oh, we're both wrong. Guess we weren't paying attention. A wire with current flowing must be wound into a coil for there to any inductance. A wire with current flowing must be wound into a coil for there to any inductance. False. Because you can measure ampacity and you measure it through inductance.
Okay.
Okay? Take one of these little meters right here. This little guy. Take these little amp current.
Wow.
That's how it's measuring the amp draws from the inductance.
I want to try that.
Maybe we'll do it after this video.
Okay.
What is the proper letter to use in a circuit diagram to indicate an inductor? What do you think it is?
H.
H?
Mm-hmm.
Why? Because the mouse went over H? Is that why you say that?
Yeah.
Oh, let's see. I.
What? What does I look like? A L.
Oh, yeah, I guess so. For a straight wire with current flowing, the right hand rule gives you what information? If your thumb is pointing in the direction of current flow, your fingers curl in the direction of the magnetic field. If you hold your right hand flat with... This is the dumbest thing in the world. Coil of wire comes an electromagnet. I'm sorry I made you go through this, Maddie. This one was dumb. An iron of ferromagnetic core inside a coil does what to the magnetic field? Concentrates it. Contactor is similar to what other component? Relay. A relay is basically an electromechanical switch.
That's
True.
always weird.
That's weird.
Yes.
A solenoid is used for what type of operations? Remote control of valves for liquid and gases, sensing movement and acceleration, sensing temperature. We're just going to go ahead and fly through this. The primary side of a utility step-down transformer on a power pole outside a house operates at 7,200 volts. That's a lot of voltage, isn't it?
Ouch, if I was in the house.
That's 7,200 volts, Maddie.
That's way too much.
Way too much.
Yeah.
So the secondary side of that transformer delivers 240 volts to the house. If the secondary side, the house side of that transformer has 100 windings, how many windings are there on the primary utility side? What do you think the answer is?
204,000.
204,000?
Yes.
Which one? 720 windings? 2,400 windings? 2,400? 30 windings or 3,000 windings?
3,000 windings.
You really want me to select that one? That one doesn't even seem right. You were right! How did you get that right? Gives you the answer right here. We're not going to do that. That's above your math grade. We failed, Maddie. We failed miserably. But we won't this time. Which one is it?
L.
Ah. Let's see how fast we can be with this. Not bad. All right. You want to try one more course?
No, thank you.
No, thank you. You don't want to try one more course?
Yeah,
You done?
yeah.
You want to take the final test at least?
I just want to build a manic.
You want to do what?
I want to build a manic.
A manic?
Remember that thing from the video it said?
Oh, a magnet, an electromagnet.
I want to build that.
You want to make an electromagnet?
Oh, yeah, I do.
Kids. So, you want to do the final test? And then we'll be done?
Fine.
Okay. This is final test of everything. What is the
What?
unit of measure for electrical power? A watt. Which of these statements is correct? Power is a rate, current is a rate, energy is a rate, power is a rate, current is a rate, energy is an amount. Power is an amount, current is a rate, energy is an amount, power is an amount. I already know the answer. What is the definition of a watt? Which one is it, Maddie?
The one with the W.
They all have W's. A flat screen TV. Oh, it's going to make me do math. Flat screen TV draws 1.1 amps at 120 volts when it's on. What is the power demand and how much energy is needed to operate the TV 6 hours? So we would need to do 1.1 times 120 times 6. What is that going to be, Maddie?
I don't know.
You don't know.
Yeah, because I don't go to the
1.1 times
Why do you? How do
120.
you know that I don't go to Duke the Bear? Do I go to Duke the Bear and learn about these things?
What?
Do I work at Duke the Bear? No.
Ow.
I go to school.
Okay, well, maybe you should come to work and learn.
That's lame.
What's lame about it?
Because I'm not a grown-up.
All right, so there it is. She's given up. She doesn't want to finish the test.
Aww.
Oh, you want to finish the test? Okay, well, let's finish the test. An electric double oven can draw to 34 amps at 240 volts when heating both ovens. What is the power demand and how much energy is used at the level for 24 hours? So it's volts times amps gives you your power, which is watts. So you do 240 times 32.
200,000.
That's kind of high.
1,000.
That's extremely high.
3,000.
So, baby, it's 240 times 34.
30,000.
Baby. The energy, you going to play along or are you going to... Okay. So, the energy is 16.32 kilowatts.
Okay.
And the power is 8,160 watts. Okay?
Okay. Do you really know?
Do I really know?
Yeah?
Yeah, I just answered it for you.
I don't know.
What is the unit of measure of energy? Is it watt, amp, volt, or joule?
Watt. Watt.
Joule. That's how we measure energies in joules.
Okay.
What is the definition of a joule?
A Jaden.
1 joule equals 1 watt pushing 1 amp for 1 second. Oh, it's 1 ohm for 1 second. Yeah, you messed up. Horrible. 1 joule is equivalent to the energy to lift 1 tomato up 1 meter. You know, this is actually a fact. This is true.
What is a tomato? Why does a tomato have to do that?
I don't know. I don't know why they determined a tomato is a measurement of energy.
Hey, I see it on my game. That fixing thing.
The what?
I see that building thing in my game. Like I see these X's. That what I see in my game.
So how many joules are stored in a battery, Maddie?
80.
No, 8,000. What is the unit of measure of electric current flow?
I do not know that because I'm not that good of electric.
Amp. Ampere. What is the symbol that represents current flow? A for amperes, I for current flow intensity, C for current flow.
How
do you know that?
because it popped out in my brain.
Okay. The direction of flow for I in an electric circuit represents the flow of what kind of charge?
You told me they have.
Positive.
I know the word positive.
What is the definition of an ampere?
What does that say?
I guessed on that one and I guessed wrong. What is the unit of measure for resistance? Ohm. Ohm. Resistance is represented in electrical current circuits by what letter symbol?
I do not think about that. How many
R.
days? How would I think about that, Dad?
I don't know. Which of these is the correct version of Ohm's law? What was that? If the voltage in a circuit is 1,000 volts and the resistance in the circuit is 20 ohms,
Hey, how long does
100
this
volts.
take?
How long is this? I think we only have like 20. The voltage in a circuit. Are we done? I can end this now.
You can skip tests.
No, we're done. We can be done. You want to be done?
Oh yeah.
You want to be done?
Mhm.
See? She didn't make it, guys.
Hey.
Well, hey, it's alright. You're just 6.
Okay.
Maybe when you come into my office, maybe next time you'll sit down and learn.
I'll keep doing it.
You don't have to do it, baby.
I do.
You don't have to.
I really
Hey,
want to.
you don't have to. I'm not upset.
Please.
It's okay.
Please.
It's okay.
I want to stay here.
You want to stay?
Mhm.
Okay. If the voltage in a circuit is 100 volts and the resistance in the circuit is 20 ohms, what is the current that will flow? Remember to use the equation, but here is a clue. So, we're trying to figure out how many amps are going to go through that. So we're going to do 100 times 20, and that's going to give us what? Or is it 100 divided by 20?
I think it's 50.
5. It's 100 divided by 20.
Okay.
It's going to be 5 amps.
This one's tricky. So you better help me with this one.
Ooh, okay. In a house, there is a circuit of 14 gauge copper wire that runs through the walls of the main service in the garage to an office at the other end of the house. And the total length of that wire is 200 feet. The total resistance of that wire is about 0.6 ohms. What is the power that is dissipated or lost as heat when 5 amps of current is running through the circuit? Remember to use the equation sheet, but there's a clue. So we're trying to figure out, so we need to square our amps. So we need to square our amps.
3. I know what it is. 3.
3.
Yeah, I count, Dad. Do I not count, do you think? I do count.
It's not 3.
8.
It's 15.
15, good job. Next time we do this, I will say 15.
It's not what the point of this is. To learn the math.
Oh.
Using the previous circuit in the house, if the current were doubled to 10 amps, what would be the power dissipation in that same 14 gauge wire?
Chugga, choo, choo.
They just doubled it. That's all they did.
Chugga, chugga, choo, choo.
I messed up. Wasn't paying attention. Hey, what is the unit of measure of electric charge? Electric charge. What is the unit of measure? Is it volt or is it coulomb?
Volt.
We still passed. You done?
Are we done?
Are you done?
Did we finish it?
Yeah, we finished it. Complete.
Yay, I want to build something like that.
Well, I'll talk to your mother. We'll see if we want to do something like that. So.
Okay, I want to pretend I want to make another video.
No, we're not making any more videos.
Aww.
You don't want to do this.
I do.
You do?
Is what?
What?
What is the video for?
I don't know.
I was just to make if I can make it.
All right, well, you ready to be done?
I think I am.
All right, say bye.
Bye.
What are we ending with? We ending with the normal theme song, or are we ending with This Is the Way?
Ending with This Is the Way.
All right, say, This is the way, suckers.
This is the way, suckers.
This is the way.
This is the way. This is the way.
This is the way.
This is the way.
This is the way.